Assalamualaikum and a very good morning. My name is Nur Syafiqah binti Rosli. My metric number is DE210032. I'm going to explain exercise number 1A, which is DC measurement of resistance. So for activity number 1, I already find all of the component, and then we need to connect all of the component into one circuit, and then we need to setting the value. So for R1 we need to put 100 ohm, and then for the we need to set up internal resistance of voltmeter, which is 10 kilo ohm. So for this one, we need to set to 10 kilo ohm, which is this voltmeter resistance 10 kilo ohm. And then after we set up the value, we have to run the circuit. So for resistor 100 ohm, we got 101 milliampere, and U1 we get 10 volt. So to find the U1 and I1 for other resistor, we just need to change value here. We just change the value here, which is 150. Okay, and then we run again. So as you can see, for I1 we get 67.667 milliampere, and for the U1 we get 10 volt. So the next resistor is 200 ohms, which is okay. Then we run. So for resistor 200 ohm, we got 51 milliampere, and for the voltage we get 10 volt. So and then we change to 300 ohms. So for resistor 300 ohm, we got I1, which is 34.33 milliampere, and for U1 we get 9 volt. The last one is 1 kilo ohm, which is for 1 kilo ohm, we got I1 is 11 milliampere and U1 is 10 volt. So this is the result for simulation for activity number 1. For activity number 2 is actually same as activity number 1, but the difference is we need to connect the voltmeter in front of the ammeter. So after we find all of the component, we need to create into one circuit, and then we need to set the value, which is R1, we need to change to 100 ohm, and then we need to set up the internal resistance of ammeter, which is 15.5 ohm. So this one we choose set, and then here we need to change to 15.5 ohm. So we need to click OK, and then we just need to run the circuit. So as you can see, resistor for 100 ohm, we get I1, which is 86.58 milliampere, and U1 is 10 volt. So for other resistor, we just need to change here. So we click stop first, and then we change here, which is 150 ohms. Okay, and then we just click run. So as you can see, for U1 we get 10 volt, and for I1 we get 60.432 milliampere. So this is the I1 and U1 value for resistor 150 ohm. Then we change the value to 200. Then we get the value of U1 is 10 volt, and for the I1 is 46.404 milliampere. So this is the result for 200 ohm. And then we stop this and then change to 300. U1 is 10 volt and I1 is 31.696 milliampere for 300 ohm resistor. And then the last one, we need to change to 1 kilo ohm. Okay, and then we click the run button and then double click. As you can see, for U1 we get 10 volt, and for I1 we got 9.847 milliampere. For activity number 3, we need to connect the circuit like this, and then we need to set the value for R1, which is 100 ohm. And then we need to set the value of internal resistor of ammeter RA, which is 15.5 ohm. So here we need to set to 15.5 here, then okay. After that, we can run the program. So from this circuit, we obtain the value of current, which is 86.58 milliampere. That we need to change the value of RL, which is 150, and then we can run the circuit. So as you can see, we get the value of I1, which is 60.423 milliampere, and then we change the value of RL to 300, get the value of I1, which is 31.696 milliampere. So this is the result for activity number 3. Next is activity number 4, which is This is the circuit for activity number 4, and then the first thing we need to do is to set the value of RL, which is 150, and then the internal resistance of voltmeter, which is 10 kilo ohm. So here we need to set to 10 kilo ohm, and then we can run the program. And as you can see, for IL we get the value of 67.667 milliampere, and for UL we get 10 volt. So after that, we can change the value of RL to 300. So for RL 300 ohm, we get the value of 34.333 milliampere for IL, and for UL, we get 10 volt. So the last one is we need to change to 1 kilo ohm. For IL, we get 11 milliampere, and then for UL, we get 10 volt. So this is the result for activity number 4 for simulation. Thank you.
Hello, my name is Yaki Sandran and my matrix ID is DE220168. So today I would like to do a simulation regarding the multi-sim which was given in lab 1. So I would like to do the activity 2 which is under the DC power. So I would like to start off by simulating the activity 2. So I would like to take the find for the power source at first. So let's find for the power source. It's at sources, power source, DC power. So we should drag it here. So it is written that they want 10 volts, so we shall edit it. Okay, following up with the ammeter. So components, it's at all groups. We go to indicators, ammeter H. Yeah. So the positive is on the left, the negative is on the right. So this ammeter has its very own internal resistance, which is given by the which is written in the lab sheet, which is 15.5 ohms. So we should configure that, and then we shall add a resistor. So resistor is at basic. It's basic. Okay, so it's at 100 ohm resistor. So we shall put it here. So we shall rotate this degrees. Okay, and then we shall connect the circuit, and the negative part, terminal of the ammeter is connected to the resistor, and then and then we shall add a voltmeter. So in this case I would like to add the multimeter, so it works both ways. So we shall rotate this first, and then we connect this positive here and the negative here. Okay, we are set to go. So now we can start running the simulation. So when I press run, so the current at this part of the circuit is 0.087 amperes, and let's check for the voltage. It's 10 volts. Okay, so for the resistor 100, we get 0.087 amperes and 10 volts. Okay, let's stop our simulation and try for different values of resistor. 150, and let's run the simulation. Oh, this time I get 0.06 amperes of current and still 10 volts of resistor voltage. So this shows that when we increase the values of the resistor, the current value decreases. So now let's try for a different resistor value, which is 1000 ohms, which is 1k ohms. Oh wait, let me stop the simulation. 1000 ohms, and yeah, we can run the simulation. So now the current value is 9.847 millis, and the voltage still remains the same. So now we can deduce that when the resistor value increases, the current value decreases, but the voltage across here remains the same. So that is my conclusion for this experiment. Thank you, and that is all from me.
My name is Noraina Masara Bentinoudin with metric number AE210028. So now I will explain about the exercise 1B, activity 1, which is AC measurement of resistance. For activity 1, the question asks us to find the value of current and voltmeter and need to compare the simulation value with manual calculation. As you guys can see, I already create the circuit for activity 1. Then we're gonna set up the value of VAC, which is 10 volt, and with the frequency 50 Hz to the circuit. We try to run the simulation by using 816 load of resistor. So when we try to run it, the value of current we get is 8.221 milliampere. Meanwhile, the value of voltage is 0.07 volts. After we get the value of simulation value, we need to compare it with hand calculation value. So as you can see at the table 1.5, you can see for load 860 ohm, the value of calculation and measurement value is exactly same. The rest value of measurement calculation for current and voltage can be found by replacing the number of loads. So that's all from activity 1. Next, we're gonna move to the activity 2. So the question asks us to find the value of the current and the value of voltage 1, voltage 2, and also the total voltage of the circuit. As usual, we need to set up the number of frequency and also the VRMS, which is 50 volts and 50 hertz. So to find the value of the load when, and also don't forget to set up the value of R1 and R2, which is R1 equal to 210 and R2 equal to 390 into the circuit. Then we're gonna run it. As you guys can see from here, we already get the value of current and also the total voltage of V1 and V2. By comparing the value between calculation value and measurement value from the table 1.c, as you guys can see, the value of calculation and measurement value is exactly same, and which is I equal to 83.33 milliampere, and voltage 1 is 17.5, and the value of voltage 2 is 32.5, and the total value between V1 and V2 is equal to 50 volts. So now is the last activity, which is activity 3. So the question asks us to find the value of voltage and also the value of I1, I2, and also the total value of current. So as usual, we're gonna set up the value of VRMS and the value of frequency, which is 10 voltage and 50 hertz. So the first so we're gonna try to find the value between 210 and 390 ohms. So when we try insert the value into the circuit, we find out that the value of voltage is 10 volts, of I1 equal to 47.62 and I2 is 25.64, and the total current is 73.26. So by comparing the value of hand calculation and simulation value is slightly same, so we can repeat the step by replacing the value of R1, R2 in order to find the value of current and voltage. So that's all from me. Thank you.